This is Dr. Carroll, and this video is about linked list exercises. Now we're going to assume that we have something like this, a node for each, that we're going to build up our linked list where it has an element and a next pointer, or something equivalent to that. Now to get started with the linked list, we're going to need to start off with a head pointer to know where is the beginning of our linked list. And we'll initialize it to something like null if we're in Java, or in C, C++. You could imagine none if you were in Python. And there we go. We started off, we have an empty list. So when head references null, then we have an empty list. Our first task is to insert 5. And so we would create an element and a node, and assign its element to 5. And notably, we need to make sure that the next reference is set to null. That's going to indicate the end of our list. Similarly, if we go to insert 3, we're going to insert it also at the beginning of the list. And so then we'd have a linked list like this. Head pointing to a node that has element 3. That next pointer is pointing to another node whose element is 5, and next is null, indicating that is the last one. If we insert 9, we're going to put it at the beginning of the list again, and we can imagine this shifting down. Now what's great about this with a linked list, we're not shifting everything down, we're inserting one node in. One way to think about it is, what if we had 1,000,000 items in a linked list? That'd be a lot. But if we did, it would take very little effort to insert the first one. We'd need to update the head reference, update the next reference to what head was. And there we go. Now let's append 7 to this linked list here. Now this is equivalent to inserting at the end of the list. And so it'd look like this. Now notably, think about how that's a little bit different. We're not inserting at the end, we're appending. Sorry, we're not inserting at the beginning, we're appending. And so we would need to find where the end is and then update it and make sure that we set the next to null to indicate that it is now the tail, it's the end. The next task is to remove 9. This is from the beginning one. Notice the reference to head has changed from the node that had element 9 to the node with the element 3. If we want to remove 5, or one that's in the middle, we're going to need to update the next reference for the element with value 3 to be the one we want to remove, the one with element 5, to its next value. So whatever value this is, we want to copy over into there, and that's going to have that effect as shown on the screen. Now if we want to remove 7, or the last one, we could easily do it by just setting next to the one before it to null as such. Now if we want to remove 3, we need to be very careful that we update head to be null. Now let's say we wanted to remove 5, we need to be able to handle that as well, that it doesn't exist. Now that was kind of pictorially how we go through it. Let's be a little bit more careful in the steps, and let's go through them. So starting off with inserting into an empty list, we're going to create a new node and assign null to the next field of that node. Then maybe that's already happens when we create it, but we need to make sure that that next field is going to be null. Then we're going to update the head reference to be this new node, and we're done. Now let's say we're inserting into an existing list. Now a little spoiler alert, this is going to be the same, we can handle inserting into an empty list or an existing list with just a little bit of careful approach to this. So create a new node and assign heads next reference to the next field of the node. Now notice if it was an empty list, heads next reference is null. And so we've handled both situations by just getting whatever head is. And then we do the same thing, we update the head reference because we're inserting at the beginning of the list. Now let's talk about inserting at the end of an existing list. We need to set a reference, a previous node, for example, let's call it that, to the node before the last one. Now, how we find that is if we have a tail pointer or we need to iterate through to get there, somehow we need it to be to the node before the last one. And now we need to create our new node and assign previous node's next field to the new node. You can go back through and see where we've done that previously in the video. And then we need to update previous node's next reference to be the new node. There we go. Now let's jump into inserting in the middle of an existing list. So again, we need to set this reference to previous node to be the node before the insertion point. Then we need to create a new node and assign previous node's next field to new node. This is feeling familiar. And then update previous node's next reference to be the new one. We could take those last two, inserting at the end of an existing list or in the middle of an existing list, so long as previous node is referencing the one before the last one, and then they're the same. We could collapse those. Now let's go on to removing. First, let's initialize previous node to null. Then starting at the head reference, what we want to do is iteratively traverse the list until the node items matches the key. So, and we're going to update prev node as we go. Now, if it's not found, then we're going to return an error or throw an exception depending on what our use case is. So assuming it's found then, if the prev node is not null, and we'll cover otherwise in the next step, then we want to assign the next field of prev node to the next field of the node that's being removed. We're going to capture that linking. We're going to copy that in to the one before. Now we need to be careful not to dereference a null reference. But if it is null, then that means it's the first item in the list. So then assign head to null because now we are dealing with an empty list. It's very important when working with linked lists to make sure you've covered all the special cases, or scenarios might be a better term for them, for each operation. And there are 4. So you want to make sure, does it work if you're dealing with an empty list, searching, adding, removing, or the beginning of a non-empty list, the middle of a list, or the tail of a list. What I think is very interesting is there's different types of linked lists. We could have a doubly linked list, a sorted linked list, or my favorite, a dummy head and or tail linked list. What happens when we create a dummy head, meaning having a node that is always allocated, so when the list is created, we create an empty node at the beginning, an empty node for the end, then that simplifies our scenarios down to just inserting into the middle of the list. The corner cases, is it this case or that case, greatly reduce. And so that's kind of interesting. Well, I hope you've enjoyed this video. Thank you for watching.